Hi, today we're gonna talk about workflow. Let's start it. So, generative AI agent workflow is there's so many things in that thing. So, for example, react, reason, act, access memory, or use query like that. So there is a bunch of references such as like IBM, so you can study about that yourself. So based on IBM, agent workflow can be described like a two part. So first one step is user query. User inputs a query and starts the AI workflow. And second, react step. First, reason. Reason. Okay? So analyze the query, identifies required steps, and breaks down tasks into logical parts. And 3, react step. 2, act. Uses tools like search, calculate, or code, executes action based on reasoning, and incorporate external resources if needed, leverages LLM capabilities. And 4, access memory. Retrieve, store knowledge, utilize historical data. In that case, now step 5 is plan, think. Iterate on steps, optimize actions, refine workflows based on observations. And step 6, observe. Monitors tool output, gathers feedback from executions. If necessary, go back to the step plan and think. And step 7, answer. Generates a final response, delivers results to the user. So this is the agent workflow by IBM story. So next thing is about reasoning paradigms. So what is that? There is 4 aspects. First one is approach. So react, reasoning and action. Reu, reasoning without observation. There's 2 parts separated. So step 1 approach, not step 1, aspect 1 approach is uses think, act, observe loops to solve problems. Updates context with each tool response. Follow step-by-step reasoning. This is react approach. However, Reu plans action upfront without observations. Anticipate tools needed based on user prompts. Avoid redundant tool usage. So, next thing is transparency aspect. Displays verbal reasoning for insight into decision making. Encourage chain of thought prompting. Reu provides upfront plans for user review, improves human-centered interaction. So next thing is efficiency. So React version iteratively uses tool during execution, may increase computational complexity and token usage. About Reu, reduce token usage and computational overhead, minimize repercussions of intermediate tool failures. Now for aspects 4 is workflow. Combines reasoning, react, combine reasoning and actions iteratively, adjust plans based on new observations. However, Reu follows a structured workflow of planning, execution, and response. Integrate initial plans with tool output. So this is the different things between React and Reu paradigms. So So yeah, workflow steps. Things like that. There are 5 steps. So first one is obviously user query, right? User inputs a query and starts the AI workflow. And secondly, there's a 3 parts can be separated. The first one is plan and think, and also it can be plan and think and reason, and it can be included in React. So in that case, step 3 can be divided to another section. It is called act. It's via tools, it can be divided. So anyway, step 2 and step 3 is something like cooperated into one. So iterates on steps, optimize action, and this is refine workflows based on observations. And analyze the query, identifies required steps. It breaks down tasks into logical steps, and uses tools like search, calculate, or code, execute action based on reasoning, is incorporate external resource if needed, leverage LLM capability. I've told you. And then next step 4, observe, can be separated. Again, observe and access memory. Because observe is monitors tool outputs, gathers feedback from execution. If necessary, go back to the step plan and think. It is observe. And access memory is retrieves stored knowledge, utilize historical data. So this is some kinds of think about the past things, and think about present, and execute about the future thing. So finally, step 5, answer, generate the final response, deliver result to the user. So this is the plan and workflow of AI agent. Okay. So let's talk about LangGraph or LangChain, a complete guide on whether to build with LangGraph. I'm gonna talk about introduction. So AI agent workflow, comparison of LangChain and LangGraph, guide to building agentic AI applications. Another information, Sandy Besson published in TDS Archive, published date October 25th, 2024. And language models unlock possibilities for user interaction with AI systems, enables communication between systems using natural language. Enterprise challenges. Choosing the right tools for agentic AI solutions is pretty difficult things. So first, the roadblock, determining which framework to use. And comparison focus, deep dive into LangChain and LangGraph, understanding key building blocks. Framework evolution. So open source competition in AI agent development, continuous updates and new features being rolled out. So that's why we're gonna use LangGraph, LangChain. Technological uncertainty. So current tools in AI frameworks might change rapidly. Encouragement to stay updated on development. And AutoGen framework. Original intention was to compare AutoGen with LangChain and LangGraph, postponed due to AutoGen 0.4 release. So because of these reasons, we need to use the free options like open source or famous thing. So the difference between how each framework handles core functionality is so overview. LangChain uses chains and agents to handle AI workflow. LangGraph organizes workflow in a graph-based structure with conditional logic. LangChain has more predefined configurations for simplicity. LangGraph offers more customization and flexibility but requires a steeper learning curve. That's the difference. And tool calling. LangChain uses chains or agents for tool execution. If in a chain, tools are predefined and called in a sequence. If using an agent, it autonomously selects which tool in invoke. LangGraph, however, represents tool as a node in graph. If an agent is included, it decides which tool to call. Conditional logic can be applied to control tool execution. So, agent-based flow, in that case in LangChain, an agent receives a query and determines if a tool is needed. The agent may invoke multiple tools dynamically. In a LangGraph, an agent determines tool usage based on graph logic. The graph navigates to the appropriate tool node for execution. So non-agent flow, in that case in LangChain, tools can be explicitly included in a chain. The chain executes tools based on predefined logic. In LangGraph, tools are graph nodes with conditional edges. State updates dynamically as tools execute. So semantic functions. Neither LangChain nor LangGraph support semantic functions like MSFT's semantic kernel. Okay, so let's think about flow for a chain and flow for an agent. Create the function that represents the tool and make it compatible with the chain. Incorporate the tool into the chain. Execute the chain. This is a flow for a chain. Now, flow for an agent. The tool is defined. The tool is added to the agent. The agent receives a query and decides whether and when to use the search tool. The agent may use the tool multiple times if needed. That's the flow of these things. So, conversation history and memory. Again, memory management. LangChain provides built-in abstraction for handling conversation history and memory. Developers can choose between different memory levels. LangGraph uses state to track defined variables at any point in time. State includes conversation history, steps of plan, and output. Granularity. LangChain allows session history, summarize memory, or custom memory. It enables long-term memory storage in external databases. LangGraph state is passed between nodes, so each node has access to the current state. No built-in long-term memory, but can be implemented using external databases. So persistence. LangChain supports persistent memory across sessions with database storage. LangGraph requires developers to create nodes for memory storage in an external database. So out-of-the-box log capability. LangChain handles complex retrieval and generation workflows. Offers built-in tools for log integration, supports document loading, text parsing, and embedding creation, includes vector storage and retrieval features, utilize LangChain document loaders, LangChain embeddings, and LangChain vector stores. However, LangGraph requires log to be built from scratch, uses separate nodes for document parsing, embedding, and retrieval connect nodes via normal or conditional edges, tracks state to pass information between steps into the RAG pipeline. And parallelism. There's four different things. LangChain supports multiple chains or agents in parallel, uses runnable parallel class for basic parallel execution. Advanced parallel processing requires custom implementation, uses Python libraries like Asyncio for asynchronous tool calling them, and LangGraph execute nodes in parallel if no dependencies exist. Supports multiple agents running simultaneously, uses learnable parallel class for parallel graphs, allows parallel tool calling using Asyncio. I'm sorry for my pronunciation. I'm not an American, I'm a Korean. Anyway, retry logic and error handling. So, LangChain. Error handling is explicitly defined by the developer. Can introduce retry logic in the chain or agent. If a tool call fails, the agent manages the error. LangGraph embeds error handling into the workflow using a dedicated node. Failed task can redirect to another node or retry. Only the failed node is retried, not the entire workflow. Graphs resumes from the failure point instead of restarting. So, in summary, LangChain and LangGraph can be used separately or together. Possible to use LangGraph with other agentic AI frameworks like MSFT's AutoGen. So, offers multiple options which may feel overwhelming. Decision depends on specific project needs. And use LangChain only when needed to quickly prototype or develop AI workflow. Workflows involve sequential tasks like document retrieval, text generation, or summarization. Agent patterns dynamically make decisions but don't need granular control. Follows a predefined linear pattern. So use LangGraph only when requires non-linear workflows with dynamic interaction. Includes complex branching logic, error handling, or parallelism. So require custom implementation for components not abstract like a LangChain, suitable for advanced workflow management. Use both together when need pre-built LangChain components like log capabilities and memory functionality. Require complex task flows managed by LangGraph's nonlinear orchestration. Combining both can extract the best features from each, enhance flexibilities and capabilities in AI development. So final consideration. Choosing LangChain, LangGraph, or both depends on the project. Each has unique strengths based on workflow complexity. The decision should be based on specific use cases and needs. Further classification can be discussed on LinkedIn. So, maybe we can talk about LangGraph. Let's explore LangGraph more. So, okay, so we need to understand framework differences. The key differences in core functionality is a base component. So LangChain method, sequential chain, or VS agent-based approach. So chains linear workflow, predefined commands, but agent dynamic decision, coordination of tasks. So chains, sequence of steps with calls to LLM tool, external data source, procedural code, or branches, logic-based splitting into multiple paths. An agent, language model, natural language response generation. Agent, enhanced capability for reasoning, tool calls, and failure handling. Tools, code-based functions for external system interaction, invoked by chain or agent. Prompt, system prompt, instruction for task completion. However, external data source injection, user prompt task definition. So how about LangGraph approach? So LangGraph, the graph-based workflow orchestration, better suited for complex logic and feedback loops. And graphs, think about graphs. Flexible workflow designed with cores to LLM tool and external data source. Flexible. Supports cyclical graphs for looping and feedback mechanisms. And so nodes step in workflow like LLM query, API call, or tool execution. Edges define information flow between nodes. Conditional edges, logic-based flow control. So state tracks current state of application, and it's good for autonomically update at each node. So agents or language models within a graph are solely responsible for generating a text response to an input. The agent can make decisions about which path to take in the graph, update the state of the graph, and perform more tasks than just text generation. The agent capability leverages a language model but enables the graphs to have multiple nodes representing different components of the agent, such as reasoning, tool selection, and execution of a tool. That's done. Okay, bye.